Hey everyone, my name is Matlock. My partner for this project you see us building here is Dominick. Me and my friend Dom don't usually build things often, so you'll get to see part of that process here. Also, I know this channel isn't usually used for this, but for this assignment we wanted to create a clean visual demonstration of airflow that we could share with y'all as well. The goal of our experiment was to visualize laminar and turbulent flow using smoke and to see how different objects affect the wake behind them. To do this, my partner and I designed and built a small enclosure. As you can see here, we used a cake box, cost about $6, and we made those shapes using note cards and tape. We used incense as a controlled smoke source. This entire project cost about $20, and one trip to Walmart took us a little under 3 hours to build and set everything up. So if you want to do this at home, I recommend it. Our first shape here is a blunt rectangular plate. You can imagine it might be something like the flat face of a building, maybe a sign. It causes turbulent wake, and as you can see here, sometimes there are nice little vortices that form after passing the object.
It just has crazy ripples.
The second shape we used was a cylinder. This one, you can imagine it's the base of the sign, you know, the pole, street lamp, mast, vertical pipe out in the wind, you know, whatever. It causes a less separated wake, and it also joins back into a plume shortly after passing the object. We also calculated the Reynolds number for this shape. So I set up a little PowerPoint here to go over the flow. Reynolds number, if it is 1 or less than 1, it's going very slow, which means it's very laminar. If it is 1 to 200, it's still laminar, but there are the occasional vortex that can spawn behind the object. And if it's between 2 and 100,000, this would be considered a transitional flow, which means it has turbulent wake after passing the object. And anything above the 100,000 would be considered turbulent. The equation for Reynolds number will be the velocity of the flow times the length or diameter of the cylinder, and all of that divided by the kinematic viscosity, which is the lowercase v there, at room temperature. You can see here we calculated the velocity of the flow by recording a video of the smoke rising 5 inches. Took 15 frames for recording in 30 FPS, so 15 divided by 30, 0.5, so half a second to travel 5 inches, which means it's traveling at 10 inches per second. Converted that to meters, length to meters, and then we plugged that into our equation and got 428.4 as the Reynolds number. which, as you can recall from earlier, means that it's in the very beginning, barely transitional flow, which means it has turbulent wake. And if you can remember, or I guess I'll show you here. Here you can see that the flow is separating with the somewhat turbulent wake after passing the object. So I'd say it's pretty accurate here. The last shape we used was a teardrop shape. It is a streamlined body, similar to the profile used in car spoilers, airplane wings, things that reduce drag. You can imagine it might be the spoiler of a car. Here we tilted the phone sideways, so you can imagine this is something flying through the air, maybe a car driving. You can see that there's somewhat turbulence, or maybe a big wake after passing the shape, but it still combines back into one plume after passing the object. All right, y'all, that wraps up our fluid dynamics project. If y'all have any questions, feel free to leave them in the comments below.
Thanks for watching, and see y'all later.